morning, children. This is my 8th class on the rate of reaction and chemical equations. Now, children, pay attention. We have already covered the different types of a chemical reaction, in which I have covered you the combination reaction, the decomposition reaction, the displacement reaction, and different subcategories of the reactions we have explained you, like exothermic, endothermic, electrolysis, that is a chemical decomposition reaction in presence of electricity, in presence of heat, that is a thermal decomposition, in presence of electricity, that is electrolysis, in presence of solar energy, that is a sunlight, it is a photochemical reactions. So all types of we have covered in. Now today's class we will be starting the double displacement reaction and oxidation reduction reaction. Then thereafter the two topics will be left. One is the corrosion and another is the rancidity. So let me cover these two types of reaction, double displacement reaction and oxidation reduction reaction. Another way also you can say that the oxidation reduction reaction is known as the redox reaction. Now it is a double displacement reaction. See, I have written it. Pay attention. Double displacement reaction. In this reaction, there is an exchange of ions takes place in the double displacement reaction. See, for example, I am going to show you the activity also. Now pay attention here. Sodium sulfate aqueous solution of sodium sulfate and barium chloride also aqueous solution. Both are complete transparent and looks like water. We have added the water, and in barium chloride also it is a transparent solution. After the reaction you will see that a white precipitate of barium sulfate is obtained and aqueous solution of sodium chloride. You will get it. This activity I will explain you. Now see, this is the transparent. How I say that ion exchange takes place. Barium, sodium sulfate, Na plus and SO4 ions it breaks. Barium chloride, Ba2 plus and 2Cl minus, it will break. Ions, there are two ions, see, sodium ions and barium ions. There is an ion exchange that takes place. Barium will occupy the space of sodium and sodium will occupy the space of barium. So barium is occupying in place of sodium, then you will get the barium sulfate and sodium chloride. So there is exchange of ions. I will tell you not only this, additional examples I will explain you. Here also see, take the lead nitrate solution, lead nitrate plus potassium iodide solution. You will see that there is a chemical reaction takes place, and here ion exchange of ions, lead and nitrate ions, and potassium and iodine ions. Again lead and potassium is getting exchange takes place, and now lead iodide, potassium nitrate. You are going to get lead iodide and potassium nitrate. This is the simply. This is the lead iodide is formed by the combination of the lead 2 plus and iodine minus. Similarly, here also barium sulfate is formed by the Ba2 plus and SO4 minus. By seeing with both the reactions, you can understand that there is a double displacement reaction. One of the displacement, that is the barium displacing sodium and sodium displacing barium. So you are getting the two sides. Now, the pay attention, I am going to explain you the activity. I will be taking the sodium sulfate aqueous solution and barium chloride aqueous solution. First, I have to prepare the sodium sulfate I will take, then we will prepare the aqueous solution. Now, see, pay attention to about that. This is the sodium sulfate. Now I am leaving it. It will be, by the time it will dissolve. By the time it will take time, it will be to dissolve. Now we will take the barium chloride. Let me take that. I have kept the test tube for other activity. Now barium chloride. See, the barium chloride color is, it is anhydrous, there is no water into this. We are going to add the water and we will show you how the precipitate will form. We are giving you, this is the barium, see, it is the barium chloride. I am taking it, this is the barium chloride. And I will add the water, then it will become aqueous barium chloride solution. Okay. Now you got the aqueous barium chloride solution. Similarly, we are getting the sodium sulfate solution. Now let me mix it both. Both have not yet dissolved properly. Now to increase the solubility we can heat it and both will dissolve faster. Then we will see the activity how the see, I am heating this. This you can remove the tripod from there and solubility will increase. See, anything does not dissolve so easily. We can go ahead to increase their solubility by yes, children, you can watch it. It is getting dissolved faster due to rise in temperature. Now it is dissolved fully. Let me see that. Let me dissolve the other also. That I have taken it. What is that? Sodium sulfate and barium chloride. It is also not getting dissolved. Let me dissolve it faster because the dissolution is not the part of activity. It will take time for dissolving. By the time my 20 minutes will be over in only doing the one activity. So let me make it fast. I am using the, and if I am preparing before that, you will say it is already made. Just a minute, we will show you this. Now the question, these two are already prepared. That these are the two solutions we have shown you. Now let me do that. What happens to this? Check it. So the change, the color took place and precipitate is formed. Now you can see this in front of you. We have made it. Children, now you have seen that white precipitate of barium sulfate is formed. Now please write both the chemical equation. We will explain to the next part. We are going to teach you the another part of that. We can also take another example of sodium chloride and silver nitrate. Sodium chloride and silver nitrate. If you are taking sodium chloride, silver nitrate, again white prefixes sodium chloride. See, another third example, sodium chloride NaCl plus silver nitrate AgNO3. You can get it NaNO3 sodium nitrate. There is exchange between ion sodium and silver, and so NaNH3 and AgCl. AgCl will be formed. Again, this is another example of double displacement reaction, which is not in your book. Now we have given you the additional one. We can go with the reactivity. Again, we can take the sodium chloride solution, aqueous solution, and silver nitrate. It is also aqueous solution, you can take it. Then what you will be getting? Sodium nitrate and AgCl. The white precipitate of AgCl will be formed. That is a white precipitate. We will get a white precipitate of AgCl. I will show you another activity for this. Now wait and watch the activity. Please write this reaction for the double displacement or another example. I need to prepare the solution for this sodium chloride. Now please watch. Show him that the camera, you can put it where. Now children, we have this. This is the sodium chloride. Daily you are taking the salt form, sodium chloride. I am putting a small amount of sodium chloride in the test tube. Add a few drops of few amount of water into it. There is no much risk, it is a sodium chloride. I can put it because here the sodium chloride, we are daily eating it and water is there, so there is no harm, it will dissolve like this. Now see, it is totally dissolved. Yes. Now you can watch it, it is totally dissolved. Is it there? Okay. Now, this is the bottle of silver nitrate solution. Silver nitrate solution. Now I will put the silver nitrate into it. For that, I don't know the chemical property, how risky it will be. Please use the tone. Then put the silver nitrate. Now look at, I am going to put the silver nitrate on this. Look at it, is a very clear precipitate is formed. Precipitate is formed. And this reaction is also known as precipitation reaction. The chemical reaction in which the precipitate formation takes place, and such reaction is known as precipitation reaction, when two or more reactants combines to form the precipitate. So you can see this is the precipitate. If you want to see more clearly, now watch it. See, this is a very clear precipitate is visible to you. It is a precipitate of what? Silver chloride. I have written it silver chloride, white precipitate on the blackboard. So you will go ahead with that accordingly. Okay, now I am keeping it. I have given you the two activities especially. One is a barium sulfate crystals, and it is a silver chloride. Barium sulfate and silver chloride. Two activities we have explained it. It is very clear. One crystal is settled, another is floating. Now what are the questions can be raised from this? What are the questions can be raised from this? What is a double displacement reaction? Explain a chemical reaction in which exchange of ions takes place. Two questions. Third question, what is a precipitation reaction? These three types of question is possible. They may ask you the indirect question. Indirect question, how it can be made. You can make yourself this question. They will ask you, and a compound X upon reacts with a compound Y. Name it X and name it Y. I will show you with a small examples. Name it X and this name it Y. It is indirect question totally, and compound X upon reacts with compound Y gives barium sulfate. And equals solution of Z. Equals solution of Z. Write the chemical reaction. Name the compound X, compound Y, and name the compound X, Y, and Z. Also write the chemical equation. Write the color of the crystal. This is another indirect questions you may face. So particularly, you try to indirect the questions. Do not go straight away for direct. Direct already in the books and you are studying it. Now let me proceed to the next topic. That is our oxidation, reduction, reaction. By the time, please write it and finish it off. I will rub it off. Now I am rubbing it off. Let me rub it off. I have tried my level best to give you the maximum activity, whatever the possible is there. Try to understand chemistry when the activity is there. It gives life to the teaching. At the same time, life to your understanding. Oxidation, reduction, oxidation, reduction, reaction. You might have thought of that I have made one weeping figure or one figure is laughing. Oxidation continue to consume, it spoil, it lose. Reduction always continue to gain, it is safeguarding with respect when I will be teaching you the corrosion chapter. When I will teach you corrosion, where the reduction will be taking places, that will remain safe. Wherever there is oxidation, it will continue to decompose and spoil. Even your wood or any substance which oxidize, get decomposed, which get reduced, it will remain for millions of years. Now, even that day-to-day life, you are burning a fuel, it is oxidation. But formation of a fuel is reduction. So formation of fuel took, the hydrocarbon took millions of years to be formed by reduction. But it takes even few seconds to burn it by oxidation. Okay, now let me teach you what is oxidation. What is oxidation? As per your class 10th standard, oxidation is the addition of oxygen in a chemical reaction is known as oxidation. Addition of oxygen. Addition of oxygen. The removal of oxygen. Removal of hydrogen. Loss of electron. Increase in oxidation number. oxidation. Children, these are all the things you are going to study even in 11th and 12th and due course in future also. Addition of oxygen we have to teach much, not that. Removal of hydrogen also we can cover it much, but loss of electron and increase in oxidation number is not in the part. Let me go to the, stick to the NCERT a little bit advanced. Addition of oxygen and removal of hydrogen is called oxidation. Now, oxidation, what? Anything you see that it is added up is oxygen. Wherever metal plus oxygen gives metallic oxide. Metal plus oxygen gives metallic oxide. Now it is oxidation. Because oxygen is added up. Which is oxidized? Metal is oxidized to metallic oxide. What happens to the metal? Metal is oxidized to metallic oxide. And it is oxygen is added up. This is oxidation. See, where there is no oxygen, it means in any reaction, there is no oxygen means there is no oxidation. It is not like that. Oxidation is mandatory, oxygen is mandatory, but without when in a reaction there is no oxygen, say for example, 2 molecules of sodium hydride is there. Now, 2Na plus H2. Hydrogen gas is given out. Now here it is oxygen or reduction. Hydrogen is removed, again it is oxidized. Here it is oxidized. Removal of hydrogen is oxidation. So here, although there is no oxygen, but it is oxidized. Removal of hydrogen. Now let me come to the part, this is a small activity. Copper, we will react with copper and oxygen. It will initially what happens? When you are heating the copper, rate of reaction is faster. Copper gets oxidized with atmospheric oxygen and forms copper oxide. That is, it becomes black in color. But it means copper becomes black in color. It is copper oxide. So you can say, sir, copper becomes black due to oxidation of copper at higher temperature. But when the copper, hot copper, if I am going for hydrogen gas, I am passing over that. What happens? Hydrogen gas, if I am passing over that, then copper oxide is reduced to copper. So initially, reddish brown color of copper becomes black due to heating, and during the heating course of heating it gets oxidized. When we are passing the hydrogen gas, the copper black color turns back to the brown again. So oxidized and reduced. By adding the hydrogen, we get it reduced. By heating, it is oxidized. So now let me explain by using the activity. Children, look at, it is your copper in a test tube. I have not made the tripod and net what it is activities in NCERT book, but I am going to teach you the same copper which is here. Now this is copper. Now let me hold it with a pair of tongs. Now this is copper. Let me light up the lamp, burner, then we will show you what exactly happens. You are going to oxidize the copper. Copper, it is not so reactive that even at normal temperature it will oxidize. In a metal, sodium is a highly reactive metal. When you are in open air, sodium is oxidized. Sodium is oxidized even in open air itself. But copper, for oxidation, you require increase in temperature. Now see. You remember that you have seen the color of the copper? Now I will show you the color of the copper after heating. Children, see slowly. You can magnify it and show it even in the flame itself, gentlemen. Here the copper is getting black. Copper is getting black. There is a problem is happening. What? This is the, here lack of oxygens are there inside the test tube. If you run it in a open, it will oxidize faster. When you run it, it will oxidize faster. You can show it. You can show it. Now it is a black. You can give me the wire also. I can show directly to them also. See, this is also a wire I am hitting along with that. You check it. I will show you double experiment by doing that. It is a copper wire, electrical wire. Now gentlemen, here I am putting into the wire. Now see, it is a black copper wire. It is a black in color. You have seen. Now I am going to put into the water. See, the blue color has come out. There is a blue now. That is a golden brown color of copper has retained. So the gentlemen, here also the same condition happens. You show it by that. See, this is your black copper. Now let me put it out. Now let me cover the topic. Now, in oxidation reduction, Cu plus O2, Cu plus O2 gives oxidation, CuO, addition of oxygen to CuO. Now, in presence of heat, copper oxide, it is a black. And the copper color was reddish brown. Now what actually happens after this, what happens in the activity, you can understand that in oxidation reaction, the copper undergoes oxidation. When copper is heated in open air, it gets converted